Vattenfall, electricity and heat generated from water, wind and coal in an ecological and economical energy mix. Another energy source for power and heat is waste, like here in the alternative fuel combined heat and power plant in Rostock. Vattenfall Europe New Energy has a wide range of experience using waste-to-energy technology. With our power plants in Lauter, in Hamburg and in Rüdersdorf, we have gathered years of technical expertise. Heat and power from alternative fuels, a valuable environmental technology with huge potential, as our latest power plant project in Rostock shows. It was developed over 3 years from April 2007 to March 2010, recycling waste in compliance with the highest environmental standards. The construction phase, an €83 million investment. The combined heat and power plant is ideally situated near a motorway on the industrial estate of an international port. It stands for a sensible energy mix in the coastal region and environmentally sustainable power and heat generation. The combined power plant in Rostock. Apart from the company's own know-how concerning power generation, a team of 28 specialists are at hand round the clock to ensure that the region is provided with heat and the German market with electricity. The Rostock power plant operators are at home here on the coast, familiar with the most modern technology and perfectly familiar with one another after an intensive startup period. The Rostock power plant, an important component of Mecklenburg-Vorpommern's modern ecological and economical waste management. Supplied with industrial and household waste of the Hanseatic city and its international visitors. Regional waste treatment plants supply the alternative fuel, some 170,000 tons annually, refined waste with high energy potential. One partner and direct neighbor of the power plant is Rostock's Municipal Waste and Recycling Company, EVG, with its mechanical biological waste treatment plant. More than 50% of the waste can be used to generate energy after separation. Separating the materials, first in a multi-stage sieve. Impurities and contaminating substances are then removed. An air separator, metal sorter, and near-infrared sorter. Using the energy contained in waste is not only beneficial to the environment, but also reduces our use of finite fossil fuels such as coal, gas, and oil. After separating the waste, the energy-rich materials are then used. It's all routine at the power plant in Rostock. All processes in the plant are monitored in the control room. The scale. At the entrance to the plant, the amount of waste delivered is carefully controlled. Here, origin and transporter are recorded, as well as composition and weight. There are some 40 deliveries per day. The incoming waste is carefully managed and controlled. Accessible via a ramp, the 4 unloading areas at the back of the fuel storage site. They allow for quick unloading even during peak delivery periods. The fourth unloading gate is where the waste ingredients are controlled. The shipments are subject to periodic random checks. The selected samples are stored separately. A grabber takes the samples, which are shredded and individually wrapped and registered. The samples are analyzed in an independent external laboratory. Different measurements are conducted to check specific components of the alternative fuel. The comprehensive analysis serves to protect the power plant and the environment, in the interest of the company and in accordance with legal guidelines. The samples are archived for future reference. The largest part of the power plant, the building of the fuel bunker for temporary storage. The processed household garbage is mixed and redistributed either automatically or manually by the crane operator. The bunker holds fuel reserves to operate the plant for several days. An automatic temperature control system with infrared camera technology combined with an independent extinguishing monitor reacts to heat development. And to avoid the release of unpleasant smells, low pressure is created and the bunker air is exhausted and used in the burning process. The grabber has a capacity of 5 tons. The fuel continuously charged to a hopper to be burnt in the boiler. The core of the power plant is the steam generator, a boiler with 3 vertical flues and 1 horizontal flue. The boiler is suspended at a height of 32 meters to allow for material expansion due to the high temperatures, which reach more than 850 degrees Celsius inside. The fuel feeders in the hopper are operated hydraulically. They push the waste onto the water-cooled grate, 25 tons an hour at most, according to the heating value. The steam generator is a natural circulation boiler. On the sidewalls, support burners which secure the startup and shutdown of the plant. After startup, the steam generator operates automatically, steered by the central process control system. The workers are constantly communicating with the system. Even the most modern measuring technology needs continual maintenance. People are irreplaceable at the Rostock power plant. But the combustion chamber is only the first part of the burner. Next is the safety evaporator, the 3 superheaters, the evaporator, and 4 economizers. In total, they have a thermal input of 87 megawatts. The fly ash of flue gas that builds up inside the pipes is regularly removed by a wrapping system. Once per shift, the wrapping carriage runs along the boiler. The ash that falls off by wrapping is discharged via hopper and troughed conveyor belt, deposited in the boiler ash silo, and then disposed of. Exhaust air from the waste treatment plant next door is also injected into the burner of the EVG. 40,000 cubic meters an hour are fed into the boiler via a special exhaust system. Everything is done in a closed cycle for the benefit of the environment and efficiency. Special underground tanks hold the heating oil for the startup and shutdown process, and for the use in the auxiliary boiler during revision periods. Steam generation in the boiler. The chemical energy of the refined household waste is transformed into thermal energy, the hot steam. It's just the first stage in the power plant process chain. The next one follows in the machine room. With a capacity of about 100 tons per hour, the steam is injected into a steam turboset. The superheated steam drives the blades of the turbine. Thermal energy is transformed into mechanical energy at about 6,700 revs per minute. The shaft connects turbine and generator, which transforms the mechanical energy into electric energy. The steam turbine is encased in a soundproof housing to prevent noise pollution. The electric current is transformed to 20,000 volts before it is fed into the Seehafen substation. The output is about 20 megawatts, electricity sold by Vattenfall. Transforming waste into clean energy according to Vattenfall's vision of making electricity clean. In addition to power generation, the Rostock thermal power plant also generates heat in the form of process steam. A special extraction condensing turbine allows for the extraction of steam at a pressure of about 15 bars. Visible from afar, the process steam pipe leading to the port area. Thermal energy delivered to consumers on the shortest way. Water of a special quality suitable for the water steam cycle is an essential component of steam generation. Drinking water from the tap can't be used here. That's why the facility has its own water treatment plant, where the water is filtered and deionized. Without this special treatment, it would react aggressively under the high pressure and temperatures, causing damage to parts of the facility. In the power plant, water and steam are moving in continuous cycles. Heating in the steam generator, expansion in the turbine, and then cooling down again. This all takes place in a complex system of pipes, around 6.7 kilometers long in total. The exhaust steam of the turbine is cooled in an air-cooled condenser. The condensate is then returned to the boiler where it is heated up again. Some of the waste heat generated by the power plant is used to preheat the feed water and to heat the building. Generating eco-friendly power from waste requires a coherent concept for purifying the yielded flue gases. Rostock has achieved values which lie far below the strict legal limits imposed by the Federal Emissions Protection Ordinance. The first phase of flue gas purification is already completed during the combustion process in the boiler via a process known as SNCR. This involves injecting urea into the combustion chamber. The urea reacts with the harmful nitrogen oxide in the flue gas stream, turning it into the environmentally neutral substances nitrogen and water. Urea, a milestone in the history of chemistry. In the 19th century, it was the first naturally occurring substance to be produced from inorganic material. Now it's being used to help protect the environment. It's injected into the boiler via an injection lance. The chemical reaction with the nitrogen oxide is accelerated due to the high temperatures. Urea injection is done automatically and monitored. The next phase of flue gas purification after leaving the boiler, the spray absorber. A lime milk suspension is injected to neutralize and isolate the acidic components of the flue gas, sulfur oxide, hydrogen chloride, and hydrofluoric acid through chemical reactions. The hydrated lime needed to produce the lime milk suspension for the spray absorber is delivered by silo vehicles. The lime milk is sprayed by a rotating atomizer with 6,000 revolutions per minute. Regular checks to ensure proper operation of the atomizer have to be carried out by the maintenance staff. In addition to the chemical reaction with the acidic toxins, the lime milk also lowers the temperature of the flue gas. The next step for the flue gases, the fluidized bed reactor with reverse function. By adding activated coke and lime hydrate, toxic heavy metals, dioxins, and furans, as well as other acidic components, are bound and isolated. The final stage of flue gas purification, the fabric filter. The remaining residues from the flue gases are trapped in the filter bags. Dust and reaction products from the spray absorber. Activated coke and lime hydrate for final reactions on the filter surface. The filters containing the toxic substances are periodically cleaned by pressurized air that is blown into the filters. Part of the filter dust is recirculated to the fluidized bed reactor to reduce operating material and the quantity of residues, and to make use of any non-reacting calcium particles, another way of practiced environmental protection. Another resource-saving step. After leaving the filter, part of the purified flue gas is recirculated to the boiler as preheated recirculation gas. Operation in closed cycles. The residues yielded during flue gas purification are collected in silos and, together with boiler ash, removed. The separated residues are used as backfill material of cavities in salt mines. The residues are mixed with alkaline liquor to be flushed underground. Within 48 hours, the suspension has hardened to fill the cracks. The cavities are stabilized. A sustainable utilization of waste product. The final stage, the power plant's purified gas leaves the plant via the chimney. Measurement devices monitor that the legal limits for emissions aren't exceeded. A continuous monitoring system that's linked with the power plant's control room. When burning the alternative fuel in the combustion chamber, residues in the form of slag are also yielded, about 1/5 of the input quantity. The combustion, on an inclined water-cooled push grate, its plates are hydraulically moved against each other. This is how the fuel is moved further along. At the end of the grate, the slag discharges into a hopper and is transported away by 2 plate conveyors. The grid plates are water-cooled to ensure a stable low temperature, which helps increase the lifetime of the grate made of high alloy material. The plate conveyors and the following belt conveyors transport the residues to the slag bunker. Directly next to the slag bunker, the loading point where the slag is loaded on trucks for transportation. Each load is automatically weighed and recorded. The potential uses of the slag produced in Rostock: covering of landfill sites and road construction. The EBS thermal power plant in Rostock. Power generation according to state-of-the-art technology. The processes have largely been automated. 3 employees per shift monitor the plant. Systematic maintenance and repair carried out by well-trained mechanical and electrical staff, equipped with an own workshop, a large stock of spare parts, and the necessary equipment is a precondition for a smooth operation of the plant. The power plant workers maintain a constant dialogue with each other and with the representatives of service providers from the region. Routine procedures and reliable cooperation. The Rostock EBS thermal power plant, a company with open doors, open to questions from the public as well as of interest for professionals from far away. Modern, sustainable energy production combined with modern waste treatment technology, issues that are of worldwide relevance. Rostock in the early evening, the end of the working day, and the start of the late shift at the power plant. Climate-friendly energy production with ecologically and economically exemplary waste disposal. Heat and electricity from domestic waste. The Rostock power plant, 54 degrees north, 12 degrees east, the coordinates of one of the most modern power producers of its kind.
Vattenfall.